Hello my dear students, welcome back to the physics class. In the previous video, we already learned some of the important concepts of our first chapter, effects of electric current. Okay, and today we are going to learn about electric power. So before that, we have to remember what is power. Okay, so what is power? Power is the work done by time, that is W by T. And the unit of power is watt, denoted by W. And now we are going to learn about electric power. So let's see. The amount of energy consumed by an electrical appliance in unit time is electric power. So electrical appliance means any of the electric appliance like oven, bulb, heater, etc. The amount of energy used by these type of electrical appliance in unit time, that is in given time, 1 hour, 5 minutes, etc. Okay, this is called electric power. And the equation of electric power is same as that of power, that is W by T, work done by time, and the unit is watt. And here work done is equal to the heat produced. Next we are going to derive some equations for finding power using the Joule's law of heating. Okay, according to Joule's law of heating, what is the equation? H equals I square RT, and here heat is the work done by the electrical appliance, that is work done, H equals I square RT, and the time is small letter t. And what is equation for finding power? P equals work by time. Here we know work is the heat generated, then the equation changes to P equals I square RT by T. In the place of H, we have to apply the Joule's equation I square RT. Then cancel T on both sides, then the equation changes to P equals I square R. This is the first equation. The second equation is derived from the Ohm's law. So by Ohm's law we know I equals V by R. Okay, and P equals I square R, that we already find. So in the case of I equals V by R. So we have to apply the value of I in this equation. Okay, that is P equals I square R changes to V by R the whole square into R. And here we can cancel R on both sides. Okay, and by cancelling R, what is the equation we got? That is P equals V square by R. This is the second equation of finding power. So what is the first equation? P equals I square R, and second equation P equals V square by R. So let's see which is the third equation. By Ohm's law, we know the equation for finding R is V by I. Okay, and here we are going to implement the value of R in the equation P equals I square R. Then this equation changes to P equals I square into V by I. Okay, then cancel I on both sides. So by cancelling I, we got the equation P equals I into V, and we can also write it as V into I. So which is the third equation? P equals IV or VI. So let's see once more the equations of power. Power equals work by time. In the case of heating appliances or electrical appliances, heat is the work done here. So the equation changes to H by T. Okay, and the second equation P equals I square R. Third equation P equals V square by R. And which is the fourth equation? P equals I into V, or we can also written as V into I. These are the equations for finding power. And the unit of power is what? Watt. W-A-T-T, watt. Okay. So these are the equations of finding power. Next one is a problem for finding power. Okay. So let's see the question. A heating appliance has a resistance of 115 ohm. If 2 ampere current flows through it, what is the power of the appliance? Okay. So, which are the data given here? 115 ohm. So, that is the resistance. And the current flows through it is how much? 2 ampere. Okay. And here we have to find out what? Power. Okay. So, which are the data given here? Resistance and current. So, which equation we have to apply here? P equals I square R. Okay. So, 2 square into 150. By simplifying, we got the answer 460 watt. Okay. So, from the equations, first we have to find out the data given in the question. After writing the data, we have to apply the correct equation. Okay. Try to do it in your home. Okay. Let me believe that you understood the topic and don't forget to read the textbook. Okay. See you in the next video. Thank you.